Welcome to this next session of Special Theory of Relativity. In this session, we are going to talk about the concept of time dilation. That is, what will be the time intervals in different frame of reference. As we have already discussed, a frame of reference that travels along with the object being observed is called as the proper frame of reference. So let us take an example. Let us imagine an object which is moving at velocity v. A frame S dash also moves along with that object with velocity, uniform velocity v. There is another frame S which is stationary, which is not moving. Now the measurements in this frame of reference will be t dash, x dash and so on. These measurements will be taken in a proper frame of reference, and these measurements t and x will be improper frame of reference. So this is improper frame of reference, this is proper frame of reference. So now we want to know what is the relation between the time intervals in these two frames of reference. According to Lorentz transformation equations, we know that time instance t1 is equal to t1 dash plus xv divided by c square minus whole divided by this factor. Similarly, t2 is t2 dash plus xv by c square divided by this whole factor. Now we want time interval, that is we want t2 minus t1. So let us subtract this. Both of these are having the same denominator. So let us write the common denominator, 1 minus v square by c square. We will have t2 plus xv divided by c square minus t1 minus xv divided by c square. Now this xv divided by c square will cancel, and what we will have is t2 minus t1 whole divided by root of 1 minus v square divided by c square. This will be t2 dash minus t1 dash. Now we know these are time measurements in proper frame of reference. So let us call this t0. The 0 indicates these are proper frame of reference, which will be equal to delta t divided by root of 1 minus v square divided by c square. V square divided by c square. Okay, let us try to understand this expression and why it is called as time dilation. As we know that this is the time interval in improper frame of reference, and this delta t0 is the time interval in proper frame of reference. Let us take some values to understand how these two frames of reference, time interval in these two frames of reference will be related. For that, we need to understand that v will be always small than c, that is the velocity of light. So we will get v square by c square always less than 1. It will be 0.1, 0.2 or some value of 0. So we will take one value. Let us take this whole factor 1 minus v square by c square equals to 0.1 to understand what is meaning of time dilation. Let us take this time interval t0 to be of 1 minute or 1 hour. Now let us try to find what will be this time interval in improper frame of reference, that is delta t. So delta t will be equal to delta t0, that means 1 minute divided by this whole 0.1. Now this will be equal to 10 minutes. This will be equal to 10 minutes. So in S dash frame of reference, which was a moving frame of reference, 1 minute measured the same time will have 10 minutes in S frame of reference. As we know that this S dash frame of reference is the proper frame of reference which is moving with velocity v. There, when 1 minute will have passed, in S frame of reference 10 minutes will have passed. That is why it is called as time dilation, because 1 minute will in S frame of reference appear to be or will be 10 minutes in S frame of reference.